Hi, this is Alex from devstories.eu, learning DSPy, episode 5 of 15. You write a clean, strongly typed signature in your code, pass it to a language model, and somehow get a perfectly structured Python object back. Between your clean code and the raw text API of the model sits a chaotic translation layer. That hidden layer is the concept of connecting models with adapters. Before we look at how they work, let us clear up a common confusion. You might mix up adapters with modules. Modules manage the reasoning strategy. They decide if the model should use chain of thought or rely on external tools. Adapters do not care about strategy. An adapter is purely the translation layer. It handles the raw string and JSON serialization that actually gets sent over the wire to the model API. Language models do not understand declarative signatures. They expect multi-turn message arrays containing specific roles and text blocks. The adapter bridges this gap. The default tool for this in DSPy is the ChatAdapter. When you invoke a module, the ChatAdapter intercepts your signature and formats it into a standard chat history. The main signature instruction is mapped directly into the system prompt. Your input fields are gathered and placed into the user message. Here is the key insight. The ChatAdapter uses specific text markers to keep your inputs strictly organized. It wraps every field name in double square brackets and double hash symbols. If your input field is named context, the language model sees a marker with brackets and hashes surrounding the word context, immediately followed by the actual context data. This visual boundary prevents the model from accidentally confusing your system instructions with the user input text. It repeats this pattern for the expected output fields, prompting the model to generate those exact same markers in its response. Consider a scenario where you are extracting science news. Your input is a raw text article, and your output needs to match a Pydantic class with specific fields for the headline and the core scientific discovery. When you pass this requirement through the ChatAdapter, it inspects your Pydantic class, generates a complete JSON schema, and injects that schema directly into the system prompt. It explicitly tells the language model how to format its text response. When the model eventually replies, the ChatAdapter catches the raw text string. It searches for the expected output markers, extracts the text block between them, and parses that data back into the exact Python objects your application requires. That covers inputs and parsing for text-based interactions, but modern language models often have native support for structured output. This is where the JSON adapter comes into play. Instead of heavily modifying the system prompt and relying on text markers, the JSON adapter takes a more direct route. It delegates the formatting constraints to the model provider's native JSON mode or structured outputs API. The model is forced at the protocol level to return a valid JSON object that contains all of your requested output fields. Because the model API is handling the structure natively, it bypasses the need for the adapter to search through raw text for string markers. If your target model supports this capability, switching your pipeline to use the JSON adapter usually results in lower latency and significantly more reliable parsing. The adapter is the rigid boundary between your deterministic application logic and the unstructured text generation of the language model. By controlling exactly how inputs are serialized and outputs are parsed, adapters ensure your pipeline never breaks due to a badly formatted string. Thanks for listening. Happy coding, everyone.